Yes.
All right. Okay, welcome everyone to our last but definitely not least session of the AREUEA virtual seminar for the summer. Just a heads up, we're going to be sending you a call for papers for the fall session that we will begin in September. Today we have Amrita Kulka presenting Under the Neighborhood, Understanding Interactions among Zoning Regulations. Thank you so much, Amrita, for being with us here. So as usual, we aim for 60 minutes of presentation time, followed by 15 minutes of Q&A, but feel free to ask questions in the chat or unmute yourselves. And I'll also be helping you monitor the chat to point if there are questions. Thank you so much.
Perfect. Thanks a lot, Luis, for the intro. Let me just share very quickly, and then move everyone to the side. So, all right. I hope everyone can see my screen now. So thanks a lot for putting the paper on the program. I had to miss AREUEA a few days, or I guess last week. And so it's very nice to be able to present to an AREUEA audience anyway. So that's kind of neat. And so this is joint work with my co-authors, Aradhya Sood, who I think is in the audience somewhere here today. Yes, I see her. And so she maybe can also monitor the chat a little bit. And then also with Nick Cumenti, who is at USDA. And so we've called the paper Under the Neighborhood, Understanding Interactions Among Zoning Regulations. And at the moment is really a great time to be presenting this because we're working on revisions right now. And so we're really excited to get everyone's input. All of your questions are very welcome. And excited to hear what people think. So let me get started. So it's an audience interested in housing and real estate. So I don't need to do a huge job motivating a paper on zoning here, but I'll do a little bit nonetheless. So the paper is kind of motivated from the fact that housing is becoming increasingly unaffordable in many cities around the world. So this is not just a North American problem, this is a much wider issue. And in Greater Boston, which is the area that we focus on, you can see that it's not just house prices that have gone up, but it's house prices have gone up relative to income. So what you can see is that as of 2018, at least 97% of census tracts had a rent or owner cost to income ratio of greater than 30%, which is the threshold for basically being considered rent burdened. And so it's really affordability that's becoming an issue here. And so at the same time, the supply of new units has really not kept up. And so the number of new units added in the 20 years from 2000 to 2019 is about the same as the number of units added from 1950 to 1970, even though the population of the Greater Boston area was dramatically different at both times. And of course, one thing we might think is, okay, if there's a lack of supply of housing, maybe one thing we could do is just add, develop vacant lots. But this is going to be difficult in the area because only about 1.9% lots in the Greater Boston area are undeveloped. And so any solution here will have to think about what to do with already built up areas as well. So potentially there could be many reasons for the affordability crisis, but one that has come under increased scrutiny in the last few years really is land use or zoning regulations. So local governments in the US have adopted many different types of land use regulations throughout the 20th century. And just a quick Google that we did about a year ago resulted in us finding at least 54 municipal, state, and national governments that have recently relaxed one or more zoning regulations. So this is really in the eyes of policymakers at the moment, and kind of a very salient policy that has come under scrutiny. And so nevertheless, we think that it's actually quite unclear how effective these reforms might be. And that's mostly because of what we know about regulations and how they've been studied in the past. And so the way we've studied zoning regulations is often in isolation. So I have papers on this myself, so I think it's very important to study zoning regulations in isolation, but it does tend to not take into account that many different layers of regulations could be interacting with each other. And so the second way that zoning has been studied is through kind of an index approach, often using the Wharton index that you might be familiar with, and thinking about wedges that regulations introduce. And so while this does take into account that there are multiple regulations, it does not really help us then to say, well, this is the regulation that policymakers should be relaxing. It's harder to do in that scenario. And so that's really where this paper comes in. So we're going to be thinking about the interactions between different zoning regulations, as the paper title suggests, and we'll be focusing on the three most common regulations worldwide, we think here. So that's number one, going to be density regulations, number two, going to be height restrictions, and then number three, a regulation which just determines whether or not multifamily housing is allowed in an area. And one thing I just want to say ahead of time here is that there are many different ways of studying zoning, one of which is going to be to write a big general equilibrium model and embed zoning regulations into this model. And that's going to help us understand a lot about the impact of zoning on prices as well as where people live. But what we're going to be doing here is looking under the neighborhood specifically. So we're trying to understand what can we learn about zoning regulations and their impact from very local variation. And so what we'll do is we're going to develop an empirical framework that helps us to use a regression discontinuity design at regulation boundaries. And we're going to use cross-sectional variation in levels of the regulation to understand how different combinations of regulations impact the supply and prices of housing units. And one thing that we add, in addition to what the literature has done before, is instead of studying zoning at boundaries which are also often city boundaries, we're going to focus on a set of zoning boundaries which don't overlap with municipal or school attendance area boundaries. So we're looking at variation within towns and within school attendance areas, which allows us to ensure that households are not sorting for any of these other really important amenities that they may care about. We're also developing a theoretical framework that allows us to think through the mechanisms behind these supply and price effects a little bit more. And in particular, we're going to highlight, in addition to sort of the option value effect of zoning, which has been studied, and the supply effect, which we think about, we're going to think a lot about the composition of housing too. And so this is a part that I'll spend some time on today because it's essentially my first time presenting this, and all of your inputs on this are very welcome as well. And then finally, I'll refer you to the paper for a very small policy counterfactual simulation that we do too, which I won't be able to get to today, but it basically thinks through the impacts of the Massachusetts Chapter 40A law, which is trying to increase density near transit stops in Massachusetts. All right, so to preview our findings, what are we going to find? We'll find that there's basically one regulation that really stands out in terms of its importance and its bindingness in the greater Boston area, and that's going to be density. And so what we find is that at boundaries where either density is relaxed on its own or together with other regulations, these are boundaries where we have the largest impact on the supply of units on either side. So 9 to 100% jump in the number of units. At the same time, height regulations on their own seem to do relatively little to impact the supply of housing. And so what we conclude from this is that in Greater Boston, density is going to be a very binding regulation, while height is not. So the wider conclusion, though, here shouldn't be that density is always going to be binding and important everywhere, but rather that for a successful zoning reform, you have to identify first what are the regulations which are locally binding, and then think about relaxing those. So in terms of price effects, what we'll find is that at these boundaries where density differs on either side, we see declines in monthly rents by between 4 and 7%, and at boundaries where density changes either on its own or in combination with allowing apartment buildings, we see declines in the sales prices of single-family homes by 2 to 4%. So these are the total jumps at the boundary, and they. So this is, basically we start from the total effect, and then we try to think about what are the different components or what could be driving these effects. And one thing that we do is we condition on housing characteristics. And so basically look at the quality adjusted jump in prices. And once we do that, we see that most of the total effect that we see at the boundary actually vanishes. And so what this suggests is that housing regulations or zoning regulations are really working through changing the characteristics of homes, essentially lowering the quality of homes, and thereby also lowering the smallest available unit in a neighborhood, which means they're essentially lowering the entry cost into any given neighborhood. And that seems to be the predominant way that zoning is working in the long run at these local boundaries. Again, for Chapter 40A, I'll refer you to the paper, but I'll just say that what we find is that it's probably the transit stops where we see the largest impact both on prices and supply are going to be transit stops in the suburbs that are close to Boston. But do take a look at the paper. All right, so the outline is relatively
Amrita,
yeah.
Two quick clarifying questions. So the first one is, when you highlight the findings, you talk about increases in density. Should we think about this as a continuous variable, or any increase in density you're defining here as having a 90% impact on jump? And the second one is, when you talk about once you control for housing quality, the differences vanish. You are talking only about observable housing characteristics and not neighborhood characteristics, correct?
Correct. So, okay, so let me start with the second question. So that's right. So when I'm talking about the housing characteristics, this is everything that is observable to us directly in terms of housing characteristics. So number of bathrooms, number of bedrooms, living area, lot size, these kinds of things which are observable to us. We do actually find that there are some boundaries, or especially for apartment buildings, there might be some unobserved characteristics which are really important here to explain rents. And I think the question also asked about neighborhood characteristics. So here, because we're looking directly at the boundary, the assumption is, and we're going to test this assumption, that there's continuity in the characteristics of the neighborhood. So what we're identifying here is really the difference in the property characteristics, and our model is going to highlight that as well. The first question was about the jump in the boundary. So that's a good question. So what we're showing at the moment, we do both in the paper sort of a per unit of the regulation calculation as well. So this is going to be, what I'm showing you here, the 9 to 109% are basically at the average boundary for a given boundary type. So the 109%, for example, is at the average boundary where density and height are going to change together. So that's the way you should be thinking about that. And then we have some per unit of the regulation regressions as well, which I'm not going to talk about today, but they are in the paper. So you can take a look at them there. So I hope that clarifies this. Okay. All right. So sorry. So just in terms of the outline, I'll talk a little bit more about the regulatory environment here, and then spend some time on the theoretical framework that we've been developing, talk about the empirical strategy, and then hopefully get to the results as well. So the types of zoning regulations that we'll be studying are the three most common zoning regulations in the United States, namely whether or not multifamily buildings are allowed in an area, which we're going to call multifamily zoning, maximum height restrictions, and then density restrictions. And for us, we're going to be measuring them, which is how the Greater Boston area does it, in dwelling units per acre. So whenever you see DUPAC, which we know is weird, that stands for dwelling units per acre. But this actually encompasses a lot of other concepts of density that you might be more familiar with, such as the minimum lot size or FAR regulations. So how did zoning begin in Greater Boston? So as I mentioned,
sorry, there's a question from Anji.
Yes, hi, can you hear me?
Oh, yes.
Yes, very nice paper. Thanks for presenting. So I was just, maybe I missed it at the beginning, but like you don't consider the external margin of like from single family to multifamily, or is it like not very common? What is the main reason why you're focusing on the multifamily only?
Sorry, so let me just follow up if this is not what you were asking, okay? So we do consider the margin between single family and multifamily as well. So we consider the type of housing as well. So again, it's one of the results. We have a lot of results which are in the paper, but what we're going to be looking at today is actually units per lot. So in some sense, that gives you an idea of multifamily versus single family already. Does that answer the question?
Yes, I think a lot of like zoning discussion is whether to convert the single family into the multifamily zoning. And then, so I was like just wondering, how should I map this result into that particular discussion? Because I think like whether we will increase the minimum lot size in the single family zoning is like completely different result from like how we're going to increase the minimum lot size in the multifamily zoning. So
yes, you're right. So I guess we could look at this because we have, in theory, we have boundaries where both sides allow either apartment buildings or both sides don't allow them. And density is changing, right? And so I think this gets exactly at the experiment that you're sort of thinking about, because of course, changing the minimum lot size when you're allowing apartments is different from when you're not allowing them. So we could look at that. It's something we haven't looked at. So this particular experiment is something we haven't looked at right now, but we definitely are able to look at places that allow apartment buildings, and we do see conversions into apartment buildings as a, so I should say, we do see units per lot being stacked essentially when apartment buildings are allowed. So we do see that on one side if apartment buildings aren't, and if they are on the other side that there is an increased probability of either a 2 to 3 family home or a 4+ family home. So we definitely do see that. But we could do the thing that you suggest, and I think that would be quite interesting as well. So thanks for that. Yeah, thanks. Cool. So in Greater Boston, the first zoning regulations to be adopted were basically height restrictions after 1917, along with broad zoning use type categories. And that's basically just a differentiation between residential versus commercial versus industrial. And so that was done in 1917, but after World War II, municipalities essentially realized that this was not sufficiently limiting the housing potential of a given parcel. And so that's when additional regulations were introduced, namely FAR was introduced and density regulations were introduced for the first time, along with this idea of whether or not apartment buildings are allowed at all. And just, because everyone's not thinking about all of this all the time, I thought I'd give one example of how these interactions can work and just to also highlight how we're thinking about them. So imagine there is a community that is of size 1 acre. It allows 5 dwelling units per acre, a height of at most 2 floors, and it doesn't allow apartment buildings at the moment. Then in this community, at most 5 single family homes can be built right now that are 2 floors tall. So that's the maximum this community can do. Now, if this, and this gets back to Unji's question as well, so if this community now allows multifamily homes, then actually that's not going to do very much over here, because while it allows those 5 units to be stacked into multifamily homes, it's not actually allowing there to be an increase in the total number of units overall. And so that's why in this particular community, you can think of density being the binding regulation. You can think, of course, of different examples. So for example, if height is limited at 1 floor, but a lot of density is allowed, then of course height becomes the binding regulation and so on. Okay, so our data are going to come from the Greater Boston area. As I've already mentioned, we look at 86 towns that are in our sample, which correspond to the towns in the sample of the MAPC 2020 Zoning Atlas. So we were very lucky that this resource came out exactly at the time when we were starting to get into this topic. And that the zoning atlas gives us essentially zoning code levels, so very fine level information on density, building heights, and this multifamily regulation. We supplement that with Warren Group information on the universe of buildings. And so this is going to be sales transactions between 2010 and 2018, as well as unit characteristics. And then we also add CoStar information, which basically gives us information on rents. All right, I'll speed up a little bit because it's already 20 past. So these are what the regulations look like. So we have our 3 different regulations. And as you can see, there's a lot of variation, and the boundaries here are basically towns. So what you can see is there's a lot of variation across towns, but there's also a lot of variation within towns, and that's what we're going to be leveraging. We're essentially going to be considering boundaries of these regulations that lie within towns. So with the 3 different regulations, we get basically 6 what we call regulation scenarios. So where either boundaries where only one regulation changes or differs on either side, or boundaries where 2 regulations differ on either side. So what I just want to draw your attention to, and so that's what these 3 lines over here say. So which ones are the ones that are changing? This gives us a different sample of boundaries basically by regulation scenario. And what I just want to draw your attention to is that the scenario number 3, which is when only density changes, is going to be by far the most common. But the other ones also give us enough variation and enough sample to be able to look at these 2. Okay, I think that's all I'd say here. And sorry, maybe one last thing here is just that if you look at the average density, height, and fraction of multifamily homes, what you can see is that this is relatively similar across most of these scenarios, but the one that really stands out here is going to be scenario number 6, where height and density change together, which has just a much higher density than all of the others. And that's what you see here. So these are our final boundaries, and they're color-coded by type. You can see that the blue ones, where only density changes, are really widely spread out. Similarly, the yellow ones are also widely spread out. But then we have these red ones here, where density and height change together, and those are really much more concentrated close to Boston or in basically the downtowns of the other surrounding cities. All right, so this is basically the part that is a lot of work in progress, but we really wanted to present just to get your feedback on whether this makes sense and what your thoughts are on this. So we want to basically develop a theoretical framework that can shed some light on the mechanisms that are driving the supply and price effects that we see at boundaries. And so we're really drawing on the whole host of literature that we have on housing production, developers maximizing underzoning constraints, and the Turner et al. Framework for demand for residential floor space as well. And so we're thinking about here a city which is divided into n neighborhoods, and each neighborhood is going to be characterized by an amenity vector an. Within a given neighborhood, they're going to be different, what we call zoning areas, 2 of them in every neighborhood, J indexed by J, and basically they're going to be characterized by a vector of zoning regulations, Zj. In every location, which is now an NJ combination, there's also going to be a fixed supply of land, L bar, and then we're going to have 2 actors here basically. So we have individuals who are going to be of type G, and they're going to be choosing which location NJ to live in. And we're going to have a number of individuals that's given exogenously to us in the city. And then we're going to have perfectly competitive developers who rent land from absentee landlords and then rent it out to individuals. And these developers are going to choose the number of housing units, the size of the housing units they provide, and the size of the land parcels that they're going to develop. I also want to say that ZJ, this zoning vector, is a zoning. These zoning regulations in general would be a vector of regulations. For today, we're mostly going to think about one regulation, but this is a vector in general. Okay, so what about the individuals problem here? So we borrow a lot of this from the Turner et al. Framework. And so basically the indirect utility of a renting individual of type G has from living in location NJ has 3 components. The first one here is going to be the non-housing consumption. So this is why income minus the price paid for housing, which is going to be basically the price per square foot of floor space times the amount of floor space consumed. The second component here is what we call the direct impact, or the utility from the housing floor space, floor space HD. And then we're also going to have the utility from neighborhood amenities, which we're going to call V neighbor. So also all individuals have an outside option, depending on their type, U-bar, that gives them some utility as well. So moving on to developers are going to make three choices, essentially. The first thing they're going to decide is the size of the lots that they are going to build on, and that's this little LJN. They're then going to decide how many units to build on a given lot, that's NJN. And basically, they're also going to decide what is the floor space that they're going to provide per unit of housing on a lot. And so floor space is produced via Cobb-Douglas production function, which is standard in this literature, which takes as inputs, on the one hand, the land, as well as structure capital inputs, so things like cement, essentially. This then allows us to write down the developer's profits per lot that they're going to be maximizing. And where's this coming from? This is basically the revenue that developers can make on one lot of land, which is the price per square foot of floor space times the floor space they're providing per unit times the number of units, minus the costs for the different inputs, specifically starting from the back, the rental price of land times the size of the lot, then what we call the skyscraper cost. So this is essentially the cost for building an additional floor, for building height. So Q times the number of units provided, and then the cost for the structural capital, which is going to be K times the capital used in one unit times the number of units. So from our perspective, we're trying to endogenize R here and P. We're going to be taking K and Q as given. And this is not crazy, because you can think of basically markets for inputs into housing construction are not local markets. All right, so I think
Amrita, if I may,
yes.
could you clarify? So you mentioned that one key thing that you're doing here is looking at the interaction between zoning areas, right? And how one affects the other. So I'm thinking about this in a setup with there's spillovers, and if I increase density in one area, then maybe single family homes production increases in another area. Is that embedded in this structure, or it seems like each developer is making decisions independently in each zoning area?
Yeah, so we're going to have the same developers. So within a zoning area, all units are going to be the same. So all provided units, all lots are going to be developed in the same way. However, I think, which gets to your point, across differently zoned areas, there will be different decisions in terms of the units to provide. So I think that does get at these spillover effects. And so we're going to talk about that a little bit right now as we think about sort of the zoning constraints and how they may enter this. And then if something's not clear, do please just come back and ask again at that point. So we're going to start with, as I mentioned, we mostly have thought this through with the density constraint, but we can actually incorporate all the different sorts of constraints that we see in our data into this framework. So density constraint here is going to be specifying the number of units allowed on land parcels. And so that's basically putting a restriction on N over L, so the units per lot. And basically what it's doing is it's restricting the number of units. So that's N upper bar. And this is as close as we could get to basically the density regulation that we see in Greater Boston. We can also we can think about how to incorporate whether or not multifamily homes are allowed in this area, which is kind of a subcase of this. So when N bar is equal to 1, then apartment buildings are not allowed. And so one lot can only have 1 unit. We can also relatively easily include a minimum lot size constraint here just by essentially setting an L lower bar. And then we are thinking that height or size restrictions can enter this by basically constraining the structural capital that's being used. Okay, so all of these can enter here in theory, but for now we're going to be focusing on the first one here. So what happens with the setup, what happens in equilibrium is we have the exogenous inputs, which is some of the prices, the zoning vector, and the amenities, as well as the model parameters of the housing production function. And then an equilibrium is given by theta, which is the price per square foot floor space, the price of a square foot of land, the choices that the developers make, as well as these two terms here in the end, where MJN is just the number of people choosing to live in a given location, and LJN is the number of lots that end up being there in equilibrium in a given location. And this is going to be theta such that households are maximizing, households of all types are maximizing utility, and with sort of free mobility, utility equalizes across locations. Developers are going to maximize profits. There's going to be a free entry condition here, so profits are going to be zero. And then land markets have to clear, which is basically the lots, the subdivided lots have to add up to the available land. And then there's going to be and floor space markets have to clear as well. So the floor space demanded has to be equal to the floor space supplied. All right, so
I have a clarifying question. So
yeah,
I think for now you're considering the density restriction, but like the minimum lot size and the density restriction could be for some reason like contradicting one another, right? So
yes.
then how should we, or in reality, like what do you observe? Is it like really are both of them binding constraint, and is it like really the tension between the two? And then is there that's my first question. And the second question is about the cost of construction, that as the number of unit increases, then there could be a economies of scale, but also I think there's a paper by Mike Erickson that the cost of construction increases as the building gets taller, because they need to like bring in another like construction material and stuff. So so I would assume that you're as of now fixing the costs of construction to be fixed and constant, or so how how do you think about those things?
Yeah, so again, starting with the second question. So our cost of height is essentially coming through this right now. So this is this Q times N that we're calling the skyscraper cost. So as the number of units increases, that's what you have to pay. So you could think about making this convex, just for simplicity. We're not doing this at the moment, but that's, I think, speaking to the point that you're getting at. In terms of the minimum lot size constraint versus density constraint, these are basically two, as you can see, N over L incorporates both N and L. So these would be two different ways of essentially achieving something very similar. So you're either constraining L or you're constraining N, which is going to limit the density. And that's also what you see in practice. So we're mostly observing dwelling units per acre, which is kind of a standardized measure across what the different communities have chosen to introduce. And so some communities have minimum lot size regulations, some have dwelling units per acre, but the MAPC has basically standardized them into the dwelling units per acre. So we don't really see a lot of communities having both of these. So it would be an either or a situation where they're achieving something similar, which is to reduce density.
Great,
So
thank you.
Cool. All right, so we had equilibrium. I'm conscious of time, but I think this is really important to get your feedback here. So I'll keep going through this relatively slowly and then speed up. All right, so we now, having put this in place, we can basically look at price differences across the two zoning areas within a neighborhood. And so in order to do that, what we'll do is we can basically, again, borrow from Turner et al., a specific functional form for non-housing consumption. With that, we can rewrite the indirect utility and then recognize that in spatial equilibrium, utilities have to equalize, which means that we can then rewrite, we can then have an expression for the difference in price per housing unit. And that is price per square foot times the amount of square feet between zoning area 1 and zoning area 2. So you can think of these as two neighboring communities, basically. So kind of anticipating our boundary discontinuity assumption, the utility from amenities is going to end up canceling out directly at the boundary. And so what we're left with here are basically the utility from the housing floor space consumed. And what I'm going to talk through next is the different effects that we think are driving this difference here. And so what we're going to show is that this is being driven at the boundary, basically by the option value of regulation. It's being driven by what we call the composition effect. So the fact that regulation impacts the type of housing that gets built. And then we're also going to show that basically we think that at binding boundaries, it's not being driven by the impact that supply has on prices, but it could instead be driven by demand effects. And I'll talk more about that in a second. So starting with the option value, this is quick, it's quick, it's a pretty established concept in the literature now, just saying that basically as regulation relaxes, this factors positively into land prices simply because you can do more with land. So mathematically, that's basically trying to understand how land prices change as regulation gets relaxed. So in our case here, density increases. And this, because it factors directly into land prices, and regulation differs by land in either community, this is going to be discontinuous at the boundary. The composition effect, what we're calling the composition effect, really is taking seriously the fact that regulation is directly targeting the housing characteristics. And so what that is essentially going to be about is how does a different level of density impact the inputs into the floor space production, which is essentially the land input as well as the structure capital input. And so what we can show is that as density increases, both the land input and the structure input actually decline in this case. And so the intuition for that comes from the fact that as option value increases, land prices get more expensive. And this means that developers are going to be parceling up land into smaller lots, so smaller L, and then also using smaller S to provide a smaller or provide less floor space per unit. Instead, they're going to increase the number of units that they build on a given lot of land. And so this effect is also going to be discontinuous directly at the boundary, again, because it's being driven by the differences in the regulation on either side. I'll skip this discussion because we're running short of time, but basically with more than one binding regulation, the developer can really, in this case, only do so much. They can decide L, S, or N. So the more parts of this we constrain, there's basically only going to be one margin of adjustment left that the developer can choose. All right, so so now we get to what we call the supply effect. And this is really this intuitive concept that we have as economists, that as regulations relax, this allows developers to build more, to increase supply. It shifts out the supply curve, and that should lower prices. So we can show that without zoning constraints, as the number of units increases, the price per square foot of floor space does drop. Was there a question? Or not yet? Okay. The thing is that for us, in our case, what we're faced with are mostly binding regulations. And so we are going to be in a situation where in the past, zoning regulations have been set, and most of these are now binding. I can't tell if someone's trying to say something or not, but I'll keep talking until someone interrupts. So zoning regulations were set in the past. Most of them are going to be binding nowadays. And then if that is the case, at binding regulations, the number of units that can be chosen is actually no longer variable. And so what we're thinking about is basically that at comparing these differently zoned areas, since the number of units is not variable, the difference in prices cannot be driven by the supply, but instead what we think is happening is that the difference in prices would be driven by demand effects that have occurred over time. So this is us trying to draw a graph explaining this basically, where we have our two different communities, which are going to be at a fixed supply of land each, because the regulation is binding. But now if there is and we have downward sloping demand curves here, which are differently downward sloping because we have heterogeneity in the characteristics of consumers, which drive the elasticity of demand on either side. So now if there's a citywide, say, increase in population, there's a shift in demand. And because of these differently sloped demands, the price impact is going to be different in either community. And so what we think is happening is that with binding boundaries, what's actually driving prices, in addition to the option value and in addition to the characteristic effects, the composition effect that we've shown, is probably these shifts in demand that have happened over time at already binding boundaries. So that's what we're calling the demand and sorting effect here. Okay, so and yeah, I'll move on for now, but it would be really great to get your thoughts on that later, but we have 20 minutes. So all right, I'll jump into our strategy. This is it should be very familiar to most of you. So I've already foreshadowed, we're thinking of using a spatial regression discontinuity design around zoning regulation boundaries to study the impacts on supply and prices. The identifying assumptions here are that on either side of the boundary, the reason there are differences is due to the regulation and not due to something else, and that close to the boundary, unobserved neighborhood quality is continuous. The way we're going to be modeling this empirically is we're going to regress an outcome, which is either the number of units per lot or the log of sales price or monthly rent. And we're going to be regressing these on a set of boundary fixed effects, so that are these lambdas, a set of time fixed effects, either sale year or rent year fixed effects, and no time fixed effects here for the number of units. And then we're also going to be regressing this on a set of bins of distance to the boundary of 0.02 miles. And basically, we'll be plotting the coefficients on these distance bins. And that's what are going to be our treatment effects of the regulation. Initially, we specifically do not control for housing characteristics here, because of course, these are endogenous to the regulation, but we'll get to that when we talk about composition. So very quickly, of course, delineation of boundaries was very likely not random. And so places that are different in unobserved ways may well have received different levels of the regulation. So we do several steps to ensure that we're looking at a set of boundaries where we're isolating the impact of the regulation and not anything else. So the first thing is we're going to take out boundaries that overlap with sort of standard things that people take out in boundary discontinuity design, such as roads, rivers, highways. But then we're also going to take out boundaries that overlap with school attendance areas and towns. And then we do another step, we go another step further, and we take out boundaries which are not straight line, because curved boundaries are more likely to have been manipulated for socio-political reasons in the past. So just to show you what that looks like, so we start with a set of boundaries on the left-hand side. And after the first step where we take out city boundaries and these natural features, we're left with the black boundary. So everything that looks like a town boundary gets taken out. And then we do another step where we're removing school boundaries and broad zone use categories. And so we're left ultimately with a set of black boundaries here. So we're removing a lot of boundaries at which households would be sorting for other reasons than the regulation. So we do sort of classic stuff to test for continuity of amenities at the boundary. I'm going to skip that because we find that both land quality as well as distance to amenities is continuous across all the different regulation scenarios. And then I do want to talk about this really quickly, because this is something we've added recently and it's very cool. So one thing you might worry about is that zoning boundaries are manipulable. So basically the running variable can be manipulated, and that maybe zoning boundaries and zoning regulations have changed a lot over time, which would be a problem because we're looking at a sort of a snapshot. Our zoning snapshot comes from a relatively recent time. We're looking at old buildings. And of course, if there were changes in between, then we're not really measuring the impact of the correct regulation. So what we've done is we've dug out a few old zoning maps. And we're going to be putting this link in our paper as well. So we're putting them online. And so we've overlaid our zoning boundaries, which are the green boundaries that we use at the end of the day, with these old zoning maps. And so here's just one example for Waltham, which is from 1952. It's a 1952 zoning map. The different colors represent different areas. And to me, it's just kind of remarkable how stable these boundaries are. And as you can see, most of these green boundaries that we study are overlapping exactly with zoning districts that already existed in 1952. And so this really reinforces the fact that we are looking at long-run differences across zoning boundaries here, and that these have been quite stable over time. You can also see that it's important to take out things like highways and other roads, because those would clearly be splitting the neighborhood into different parts that are not comparable. All right, so in the last 15 minutes now, I think we're good on time again. So feel free to ask questions if you have them. Let's talk about results. So we'll start with the number of units per lot. And so, as I said before, what we're basically doing is we're regressing an outcome variable on bins of distances to the boundary of 0.02 miles, as well as boundary fixed effects, and plotting the coefficients on these distance bins. Everything that's going to be to the left of 0 here is the relatively more restrictive side of a boundary. So think lower density, lower height, not allowing multifamily buildings. Everything that's to the right is the relatively less restricted side of the boundary. So think higher allowed density, higher height. And we're also normalizing the the first bin on the less restrictive side to 0. So everything's going to be relative to that. So at boundaries where only density regulations change, we find a significant, or we find an increase of about 8.7% in the number of units per lot. So as density increases, we are seeing more units stacked basically on one lot. When density and height change at the same time, we actually see this really big jump of 109%. So at this point, there's really, and this is really getting, I think, to Yunji's question from before as well, is these are really places where we're stacking into apartment buildings a lot more. We also,
Amrita,
yes.
These 109% or 2.6 units is comparing the average before and after, right?
So, well, not before and after, because we don't have effects over time, but it's relative.
Yeah. Oh, yeah. Before and after the spatially.
Exactly, before and after spatially. So it's relative to the less restrictive. So it's flipped here, but it's relative to the average on the less restrictive side of the boundary. We basically have 109% decrease here on the more strict side.
And here it's the number of units
per lot.
Per lot. Okay.
Per lot. So this is basically a doubling of the number of units per lot. So stacking up into apartments, or at least multiple units, row houses, townhouses as well.
I think there's also a question from Eric.
Okay.
Yeah. Sorry. Can you hear me okay? Yeah.
Yes, absolutely.
I just wanted to make sure I'm still understanding this right. Is it the case that if these regulations were put into place in the 1950s and they said, okay, here's a section of town with tall buildings, so anything to the left of that which doesn't have tall buildings, we have a height restriction, but the place that does have tall buildings, we don't have a height restriction. And then you look today, things are pretty consistent over time. You'd find that there's a really big change in height across this boundary, but this is the endogenous regulation question. Like, can you somehow separate out changes from when this was put into place to now, as opposed to what was already existing when the regulation went into place, or a way to test whether the regulation was put in place because there were pre-existing density or height differences across areas?
Right. So exactly. So that's so we tried to do sort of several things here, right? So I showed you that the regulations that exist, the boundaries that we're studying today are basically very similar to the boundaries that were introduced when these regulations were introduced. And your question is, how much was this based on already existing, already pre-existing regulations? So one thing, at least from historical sources, it seems that a lot of these were really introducing new concepts, right? So there wasn't enough density, there wasn't enough lack of density. So there wasn't the density wasn't low enough. And so these were new regulations being introduced in areas that maybe did have some apartment buildings before and so on. So I think that's one way of answering it. At some point, we've done a test also, kind of a placebo test as well. We did take that out in the end, but basically looking at the characteristics of buildings which already existed pre-1918 when the first zoning was introduced and pre-1956. And I remember that for density and height, for sort of the continuous variables, we found that there is no prediction. So today's regulation doesn't predict the characteristics of these older buildings. So we did that as well. It was a bit, so I think for multifamily homes, we found some very slight predictiveness in some cases, which I think you can understand to mean basically that whatever is the center of town today was already the center of town back in the day. But so we did these kinds of exercises, which
Amrita, sorry to interrupt, but I should say that these results you're seeing are all buildings that were built after 1918. So after the first regulation was removed, you can also restrict that to all buildings built after 1956, right? After, that's the point where regulations stop being added, and that's in the paper. This is after 1918, so we're already removing in all our supply effects anything that was built before. So that sort of addresses the concern.
That also addresses it, exactly. So this should. Yeah.
The other thing you could, I think, possibly do is take it. I mean, if you have like a 1940 map or something like that of the city and do the like AI prediction of where these would go into place and somehow use that instead, because it's just so hard to accept that these are randomly carved streets throughout the city. Like
sure,
it's just tough to, I don't know, understand why they would do it that way. Is it?
Sure. Yeah. So we can think about we can maybe think if that's something that we could add, as well. So I hope that you've already seen, we've done our best to really exclude a lot of boundaries which are problematic. And so what we think we're left with is basically areas where city planners have kind of decided this is where we want a zoning. So this is how we think the city might grow. And so here's where we're drawing a boundary, but yeah, maybe we can think of something, a predictive exercise as well. Okay, so all right, so this is for at boundaries where density changes on its own or together with height. We also have boundaries where both the density changes as well as whether or not apartment buildings are allowed on either side, and we find a jump of about 53% in the number of units per lot at such boundaries. And then we also find a very similar increase in the number of units per lot at boundaries where the only thing that's changing is basically whether or not apartment buildings are allowed. So basically we do see, again, some sort of reorganizing into multiple units per lot. So now these are our height results. And this, trust me, is not that we don't just find effects here because this is a small sample, but actually even when we had a bigger sample, we never saw any impacts on the number of units per lot when height regulations change either on their own or together with allowing apartments. And if you think about it, this isn't a crazy thing to happen. So if you think about what these different regulations are doing, density is very clearly targeted directly at the dwelling units per acre. So of course we would expect density or any combination of density to impact that. Height, on the other hand, the only thing height is doing, fixing the other regulations, is essentially varying the size of the property. And so it makes sense that we don't see a lot of impacts on units per lot from only relaxing height. And then multifamily zoning is indeed kind of a bit ambiguous, because on the one hand, and we see that, we do see sort of a change in the type of homes towards multifamily homes, but area-wide density still shouldn't change here. All right.
Sorry, Amrita, could you repeat that interpretation of why we don't see an effect on heights?
Right. So imagine the only thing we're changing is we're allowing an additional floor, and we're keeping fixed the number of dwelling units per acre we're allowing, as well as whether or not apartments are being allowed. Then all we're doing is saying the single family homeowner can increase their house by one additional floor. essentially. That doesn't mean that there's an additional unit put in. It's the same amount of units, the units will just be bigger.
Right.
Make sense? Okay. All right, so in my remaining 5 minutes, maybe I will invoke the 5 minute. In Wisconsin, we used to have a 5-minute rule in the end. So I'll take questions afterwards. So what we can look at as well, and this speaks to the composition effect that we've included in the theoretical framework. And so what we can see is that at boundaries where density changes, similar to what the model predicted, basically we're going to have a decrease in the number of bedrooms. You can do this for bathrooms as well. And we have a decrease in the lot size. So this is basically a reduction in the floor area, the floor space provided. At boundaries where density changes along with allowing apartment buildings, we also see a decrease in the built area. So this is kind of the living, this is the living area essentially. We don't see very much here on lot size. So that's basically might be saying that on the one hand, we have sort of bigger lots with apartments on them, and on the other hand, we might have smaller lots with single family homes on them. And then when we, at boundaries where density changes or differs along with height, we actually don't really see much of a difference here in the property characteristics at all. And again, this might be given by the fact that these boundaries were located quite centrally in places where these might already be relatively small. And so all that's happening at these boundaries is more units are being added, but not necessarily smaller ones. All right, so to sum up, I don't think I need to sum all of this up. The only thing I'm going to say is I'm now going to show you price effects, basically, but only at boundaries where we found supply impacts. Okay, so I'll start with, again, boundaries where only density differs on either side. And what we see is that rents fall by about 7% on the less regulated side of the boundary, and the sales prices of single family homes fall by about 4.5% on the less restrictive side of the boundary. So these were places where we saw impacts on the supply of units per lot. We're also seeing impacts on prices here. Similarly, or not similarly, but when density and height change together, this is a lot less clear. But if you expand the bandwidth to some extent, you find decreases in rents by about 4%. You really don't see much for single family home prices at boundaries where density and height change together. And then finally, when the only thing that changes is whether or not apartment buildings are allowed on either side, you're not seeing very much here in terms of the prices of single family homes. Again, depending on the bandwidth, you do find something at boundaries where density is relaxed and apartment buildings are allowed, about a 2% decline in prices. So in my very last 2 minutes that I have, let's go back to the framework and think through what could be causing these differences. And so what we're going to do is we're going to take our price effects, and I'll show you the same regressions, but where we've conditioned additionally on property characteristics. And that's what I'm showing here. So the red and blue is what we had before, basically. And once we condition on the observable property characteristics to us, that's what the gray lines are showing us. And basically, in the case of boundaries where only density changes, and for sales prices of single family homes, almost the entire impact of the regulation vanishes essentially once we condition on property characteristics. So if you think back, so this is a very, very strong, what we're calling composition effect here. And if you think back to the figures that I showed you about the characteristics of properties, there were also big differences in number of bedrooms, bathrooms, lot size, and so on. If you think could there be sorting going on here or option value effects? Potentially, but they would have to be somehow canceling each other out or be relatively small in this case. Similarly, at boundaries where density is relaxed and apartment buildings are allowed on one side and they aren't on the other side, we again yet most of this effect is appearing once we condition on property characteristics. So again, a pretty big composition effect. If we look at rents, the story is actually just slightly different. At boundaries where only density changes, yes, there is something happening here. So we do see a small reduction in the impact that we saw, but it's less certainly than we saw for single-family home prices where the entire effect just vanished. So the way we are interpreting this is there is some amount of composition effect going on here as well, but potentially for apartment buildings, there are characteristics which we're not able to measure on the more restrictive side of the boundary that households could be sorting on, which continue to drive price differences at these sort of boundaries. And then when density and height change together, actually, if anything, the confidence bands here become narrower. And so if anything, we have kind of a more precise effect than we had before. And again, our way of thinking about this right now is there might be sorting on unobserved characteristics happening at these boundaries. If you think back to the characteristics that I showed you, there was almost no discontinuity in property characteristics at these types of boundaries. Okay, so I think that basically brings us to the end. So what do we make of this? So it seems that zoning regulations in the long run and at these boundaries are predominantly affecting the characteristics and the quality of housing, and essentially leading to a stricter regulation leads to an increase in the price per unit for the smallest available unit on the restricted side through an increase in quality. But nonetheless, if the goal is to reduce prices and rents, we might care about the price of the smallest available unit. So essentially, stricter regulation is making some households overconsume housing, and it's raising the prices for consumers with a low willingness to pay for high quality. So that's it. Let me just conclude. So I hope that I've convinced you that which regulations are relaxed matters. In our case, what we find is that density has a very strong and binding impact on supply and prices of housing, whereas just relaxing height has less of an effect on the supply of units. I also showed you that combinations of density and other regulations are most effective at lowering rents as well as single-family home prices. And we showed that most of these price differences seem to be due to an induced difference in quality, which we call the composition effect. And that's what's really driving the difference in prices for differently regulated areas. And just looking at these very locally, sort of under the neighborhood, allows us to study that in quite a lot of detail and hopefully quite convincingly as well. So that's it. Thanks a lot. I'll stop sharing so I can see all of you.
Thanks so much, Amrita. There is, let's open the floor for questions. There was Sanmo in the chat said that they had a question first. So let's begin with that, and then we'll go with Eric.
Hi. Hi, everyone. Can you all hear me properly?
Yes.
So yeah, lovely presentation. It was quite informative. I had one question regarding, since you were focusing more on the regulatory aspect for the pricing of their houses. So I just wanted to hear from your end whether you considered like which political party, for example, let's say the Democrats or Republican, whichever it is in power in Boston, which could potentially affect the outcome of driving the regulatory like constraints. Because, for example, there's this paper in England where they focus on the like when the Labour Party won. So their objective is more towards affordability, housing affordability. So they kind of put more restrictions in general. So like my question to you is, did you look at this dimension for this research?
Yeah, thanks for the question. So, I mean, true answer, we haven't looked at this yet. One main reason for that simply being that there are very little, so I think changes in regulation is something that's a lot more studyable now. So we had to use this, we were using sort of cross-sectional variation. And so I think for a lot of the policy changes that are coming now, I think these kind of questions are going to be a lot more relevant. We did look a little bit at some point as at just the form of town governance, and so how different forms are governed, and if there's kind of a more representative form of governance versus a less representative form of governance. And we did find some impacts basically of that. So basically what you find is when there's more representative forms of town governance, less supply gets built overall, but it gets distributed around more. So that, but there's also, I mean, we weren't the first people to find that. So there's people who found that before us. So that speaks maybe a little bit to the political economy here, but we haven't looked at anything like elections at the moment. But it's definitely a good.
That's pretty good. Just another question on the other hand. Did you take a look at the geographical constraints in any way, like digital elevation models or land use, land cover? Just a curiosity.
Yeah. So we haven't done any kind of heterogeneous. So right at the boundary, these things don't differ, right? So we show that there's continuity in the quality of land, which could definitely impact what gets built where, but it's continuous. So we didn't, so at the boundary, it shouldn't matter, but we haven't done any kind of, you know, looking at whether you're near the coast versus further away, something like that. So we haven't done that yet.
Okay, I mean, in general, I don't have a very good idea about the landscape of Boston, but I think it's fairly flat. So anyhow, it wouldn't.
So again, you could look at water closeness versus not.
Probably the coastal areas, you can take that into consideration just to like probably make your model much better. So yeah, thank you. I enjoyed it a lot.
Thanks.
Eric?
Yeah, can you, I might have missed this or the connection, but can you just say again how you're trying to interpret the price effects? Because I don't quite understand that here. I mean, if you have like your best case scenario where you're splitting a neighborhood in half and you have similar homes on both sides and they're sharing the exact same market and the exact same amenities, then why would you expect the regulation to have any effect on price? Like, I could understand a little bit the price, the house price version of it, if it's the option value of future renovation to the house, or maybe you're expecting the regulation to change or something like that. But especially rents, how would you interpret a rent difference across this boundary? I don't quite know what you're looking for there, how to interpret.
Yeah. So I guess that's what we were trying to do a little bit with the theoretical framework, to try and get at that a bit, right? So as you were saying, there are some things which are fixed, which are driving differences, namely the option value, which is always going to create a price different in land prices in differently regulated areas. What we are also showing is that this composition effect, so the quality differences, are going to impact both prices and rents as well, right? So insofar as the regulation introduces different types of units or differently composed units with smaller floor space and so on, that of course will also impact both rents and prices. And so we do show that, and we show that when we condition on that, at least for house prices, that takes away, that kind of explains most of the effect there.
Okay,
for rents,
so you're not trying to get at kind of pricing in this regulation and how it affect rent. You're looking at just how it has affected the quality of units over time, kind of that's your interpretation here. We're
looking at the total price and then trying to decompose that basically as much as we can. So yeah, we're not, so Turner et al. Have kind of looked at how the or were the first to look at how the regulation prices into land. And so we've run that as well. So we can look at the impact of prices on land, and you will get the opposite of what you see here, right? So you will get that the more restricted side of the boundary has the lower price per square foot of land than the more relaxed side. So we've looked at that, but we were really focused on the, first of all, getting a good estimate of this total price and then understanding where it's coming from. And so in as far as option value is there, it does seem to be canceling out with sorting of some sort on characteristics, which at least for the rental units, I think we're worse at observing.
Okay, thanks.
Cool, thanks.
Amrita, you talked a little bit about the potential endogeneity of these zoning boundaries.
Yeah.
But not so much about the endogeneity of the zoning restriction themselves, right? So it's two things like that I can think about. Like, you know, historically these zoning boundaries were defined, and let's even assume that they didn't change at all since the 50s, I think it was, that we're looking at them. So that is what determines, you know, which area has a different zoning designation. But then you also have zoning boards, right, that are local and that define through an almost like an election process, the designation of that zoning area. And so how do those two interact in Boston?
So,
do you have like a different body choosing for each one of these zoning areas? I assume they're not. They have one body for multiple areas, but not just one for all of Greater Boston.
Right. So it's usually by city. So these things are very sort of local, very localized. And there's often, so this I know for Wake County, where I have another paper that looks at data from Wake County, and there you get basically a baseline zoning that the county decides, and then cities have their individual zoning codes on top of that. But if you're not incorporated, you get kind of the baseline. That's less of the case over here. I think what you're asking, if I understand you correctly, is basically about the one thing is the boundary and one thing is the level of the regulation, right? That sort of is, maybe that's what you're asking. And the boundary, I think I showed you, is very similar to what it was introduced at long ago. And the level could be different. So we didn't find any big overhauls in the zoning code. So we've looked
I guess my question boils down to, is zoning a location characteristic, or is it dynamic?
Right. And so the way, again, so there's Jeff Zabel and Dalton have a paper looking at kind of a similar area where they sort of tried to figure out how much these regulations change. And you can look at rezoning requests. And I think the answer is, up until now, not very much. Now, if you start looking at it, everyone's making changes. So there's 40A, there's other kind of ways that policies that are changing the codes, the zoning codes in a big way. But for the period that we study, we didn't find any sort of big overhauls in the zoning code. We can go through and look at probably how many rezoning requests there were or something like that. And so we could look at that and just see how much that is. But just from experience from other contexts too, it tends to be, during that period, it was very little. So I think you can think of it, I guess, which means that to your question, maybe it is more of a characteristic of an area at the moment.
It would be very interesting, since we're seeing this movement, to use your model to kind of predict what are the potential changes in value to be gained or lost for incumbents of an area, and kind of predict the places that your model would see changes in zoning, and then contrast it with whatever we're seeing.
So it's been something that I've written. So of course we're doing a local regression discontinuity design. So we cannot, we cannot say massive, we can't do a massive zoning counterfactual in good conscience at all. But at least what would be cool to think about, I think, is to think about a city that has some kind of whatever regulations in place, apply this framework and basically figure out what are the binding regulations, right? Because I think in a lot of places, and Yunji pointed this out, what policymakers are really focused on is the single family only zoning. And that might not be what is binding. What's binding is density. So if you're just relaxing one and not the other, something may just sub in essentially, and you're not going to have much of an impact. So we haven't really found a good a clean, so because there were so little changes, so we even tried looking for a while at what are cases where regulations have changed in the past where we can apply our logic to, but it's so hard to actually find areas where there were sort of big detectable changes in zoning that we haven't found a good place in the past to do this. We could try and do this now, and I think that would be really cool.
But you have the historical zoning maps, right? So you, even though you said like there's not a lot of changes, you would see a change if it had happened.
Well, we found some historical maps for some towns, so we definitely don't have a time series. So we found probably what is the first comprehensive zoning code for 12 towns, something like that. So we found some of them, but we don't have changes over time for that at the moment. But yeah,
I think that application in general to the changes in zoning, and it's great that you can estimate parameters that one thinks are estimated in a period of stability, and then some even if there's limitations with the methodology. So it's 12:15. Let me stop myself from asking more questions, and then are there any remaining questions from the audience? All right, so thank you so much, Amrita, for coming, and stay tuned, everyone, for the call for papers for the fall session.
Thanks a lot, Luis.
Thanks so much, Amrita. This is super cool. And I see that everybody's leaving, but if you have 1 minute, I had one remaining question about the binding versus non-binding zoning. Do you see that? Do you observe, for example, heights? And so can you tell if height restrictions are binding in an area or not?
Yes, we do. So we've so I mentioned briefly in the presentation that that dwelling units per acre are kind of a summary measure in this case. So some towns have dwelling units per acre, some have minimum lot size, some have FAR. And so we've used, and it's combined, the one that ends up being the most standardizable is dwelling units per acre. So the problem with density, so for height, we tried to compute bindingness for density by basically looking at what you actually have to do is figure out the minimum lot size, figure out the realized lot size, divide those by each other, and figure out that quotient. And you can do the same for height. You can look at the amount of feet height restriction and realized and do that. So the short answer is it's something that is still left to do properly. So we've done kind of a quick version of it, but what becomes complicated is density is an area-wide concept. Minimum lot size is a lot concept. So minimum lot size you have to measure at the lot level, and that's easy. With density at the area level, you actually have to find the relevant area and calculate it that way. And so that part takes a little bit longer. But for height, we should be able to do it, and we haven't done it yet.
What I was thinking about is just the simple height restrictions, and whether if you had two different height restrictions between, across, before and after a boundary, and they were both non-binding, then it would kind of make like a placebo test, because you shouldn't see any effect on anything if those restrictions are non-binding, right? But you're right, there's a lot more complexity in the other types of restrictions that you have to consider.
But you're right. So we could, there would still be an option value that should show up, right? But there shouldn't be, we would expect there to be much less price effects, right? So there wouldn't be any composition effect.
And if that was very widespread, you could actually use that to test the option value, right? Like that would only capture them.
So it's a good point. Generally, the issue is, especially in places like Boston, that these are really binding. So at least density is going to be really binding, but I take your point, and we should look into how much of this we can do. So thanks a lot.
All right.
Thank you so much.
No. of
Thank you
course.
so much.
All right.
All right.
Thank you so much.
Yeah, bye. Have a good one.